Hi everybody, we're going to have a quick look at prime decomposition. Prime decomposition reduces a number to prime number products. Products meaning times, prime number meaning numbers times by itself and 1. One way to do this is by reducing a number to factor pairs to prime numbers through a factor tree. Let's see how that's done, but first of all we have to look at what prime numbers there are. And I made a little list here to make it easier for us later. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. Unless I've made a silly mistake, are all prime numbers. They only have factors of themselves and 1. Now to do some prime decomposition, we need to put the number to factorize at the top of a tree. We need to branch the factors under the tree into primes, into composite numbers until we're left with only primes. So here's how we do it. We start with the number that we're looking for, so we're wanting the prime products of 24, and 6 times 4 multiplies to 24, so we're going to stick those underneath. We can choose anything other than 24 and 1. 24 and 1 won't work. So we get 6 and 4. 4 isn't a prime number, 6 isn't a prime number, so we go again. The factors of 6 are 3 and 2, the factors of 4 are 4 and 2, and then we circle all the branches at the bottom of the tree, and we can find the prime factorization. So the prime factorization of 24 is 3 times 2 times 2 times 2, which I've written over here, and if we use our indices, we know that that's 3 times 2 cubed. Let's have a look at 12. 2 multiples of 12 are 2 and 6, or 12 can be factorized into a factor pair of 2 and 6. 2 times 6 equals 12. 2 is a prime number. We can put a little square around it. 6 is a composite number. It has factors other than 6 and 1. So we'll do another branch. And 3 and 2 multiplies to make 6. Once we've got to that stage, we can write out the prime factorization. The prime factorization of 12 is 3 times 2 times 2. And if we multiply this, 3 times 2 is 6, times 2 is 12. They're the correct prime factors. Reducing it to index form, 3 times 2 squared. Let's try another one. 36. Factors of 36 other than 36 and 1 would be 12 and 3. 3 is a prime number, put a square around it. 12 is a composite number, split it again. The factors of 12 other than 12 and 1 would be 6 and 2. We could have used 3 and 4, but this time we've used 6 and 2. Branch it. 2 is a prime number. 6 is a composite number, so we go again. 3 and 2 multiply to make 6. We now have our prime factors. The prime factorization of 36 is 3 times 3 times 2 times 2. The order is not important. As long as we have them grouped together, it's easy to see them as indices. That's 3 times 3, that's 2 times 2. There it is there. If we put the prime factors into our calculator, we should get the original number. So if we want to put 3 squared times 2 squared in our calculator, 3 squared, it depends on if you calculate, it's got a squared button. In this case, I've used the x with a little square above it. 3x, make an index with the power of 2 times 2, make an index with the power of 2 equals, and we'll get the 36 that we require. Here's a few more examples. 28 has factors of 14 and 2. Circle the 2. Put a square around the 2 in this case. 14 is a composite number, split again. 7 and 2. The prime factors of 28 are 2 squared and 7. 15 has 5 and 3. Both 5 and 3 are prime, so factorizing it with prime factorization is quite simple. Same with 14, it's only got 7 and 2. 7 and 2 are both primes. If we start with a prime number, we only end up with a prime number. We don't have to factorize any further. I hope that was helpful, everyone, and I'll see you in the next video, or at least you'll hear me. Thanks, everyone.